So this video is going to talk about stress and strain so you can gain an intuition for what it means, because it has a wide variety of applications and the way that this interacts with other objects can get slightly confusing, so it's important to distinguish between stress and strain and other aspects of engineering. So just to refresh your memory, engineers essentially what they do is they combine and rearrange atoms to their advantage. Their only competition are forces of nature, because I'm not sure if you're aware of this, but AirPods aren't, they don't spontaneously form in the middle of the desert and somebody collects them. Mercedes actually don't grow on trees, and anything Elon Musk sends into space, it isn't grown naturally in the ocean or anything. He actually has to figure out how to manipulate atoms and, send something into space. And the same thing goes for essentially anything which is quote-unquote unnatural. So engineers need to acknowledge that what they're building is against the forces of nature, and they need to figure out how to counteract all of these issues that they may come across. And there is a lot. But the fundamental idea behind all of it is the forces between atoms and molecules. If engineers can figure out how these things behave, they can pretty much build anything. So, if you think about it, engineers are the ultimate Jedis. So how do engineers manage to win in the long run? Nature has been around a lot longer than we have. So what's our secret? Well, we actually use the laws of nature. We figure out how everything works and we manipulate it to our advantage. Which brings us back to the content of the video, which is about stress and strain. So all stress is the amount of force over an area of an object, which is known as stress. I'm just going to repeat myself there. Everything in existence will have some amount of force in some direction pushing on it. And the formula for stress is just the amount of force over the cross-sectional area. So you've got one person jumping on a trampoline here. They might be exerting, say, 1,000 newtons, 500 newtons on this small area. But these guys, they've got a much larger area. There's a lot more force. So the amount of stress experienced here will be much higher than this small area here. And there are actually three primary ways forces can be applied to an object, or there are three primary types of stresses. That is tension, compression, and shear. So tension are the forces which pull objects apart, that pull atoms away from each other, molecules away from each other. And you can see them in bridges, you can see it in surface tension, or if you can look at atoms with your, naked eye, you could also see them in tension as you try to pull them apart, and these nets at the back of catamarans. Next up is compression, which is just the pushing force that pushes things down. So if you have a look at these columns here, they've got a lot of weight on top of them, so they'll be in compression. And lastly, we also have shear, which is a force parallel to the ground. Now, it's not necessarily always parallel to the ground, but it's a good foundational way of thinking about it. So shear, actually, if you have a look at the etymology of it, it means to cleave, cut, with a sharp instrument. So if you think about a force parallel to, the natural direction of where the object is going, so this is going up, then the shear force would be going this way, cutting right across it, which explains the word origin. So here's a quick summary. So here's the compression, what compression looks like, tension, pulling it apart. Bending is actually a type of complex stress-strain state. We'll get that into another video. Torsion is a type of pure shear, so we'll get that in another video. And then we just have shear, as mentioned before. As you can see, it is just parallel to the ground there. So next up is strain. Now, usually when you put force on an object, it deforms or is permanently damaged in some way. So engineers give this, when this phenomenon happens, they call it strain, and it measures the amount a material deforms. So it is calculated by the change in length over the original length. This is axial. Strain can happen in many directions, but this is just a general overview of stress and strain. So strain is given as a percentage, which could be negative or positive depending if the deformation resulted in longer or shorter length. So obviously if something shrinks and it was originally long, it has experienced a decrease in length, so your percentage change is going to be negative. Now, not everything deforms a whole lot. Things can deform to an extent, or they may not deform at all. For example, China, when you break it, it won't deform much, so you can usually piece it back together, but metal, it deforms a lot. Once it's been deformed, there's not really a great chance of you putting it back together unless you use some extreme heat or mechanisms to melt it and remold it. So, now you should know that engineers manipulate laws of nature with laws of nature. To understand how to contend with forces of nature, engineers need to understand that there are three main ways a force can be applied over an area, that is tension, compression, and shear. Engineers should also understand that a force will sometimes deform an object, and this is known as strain. So the next video will investigate shear, stresses, and strains in greater detail.